Happy Thursday, everyone. If you've joined any of these before, you'll probably know I'm Matt. I'm the MD at BIMA. I'm going to bring it up straight away, Andy. We're matching twins today in our outfits. We've just realised. I hope you're all wearing some old school Adidas sweatshirts today just to fit in with us all.
Yeah, it took a lot of coordination, so I hope everyone appreciates it.
Yeah, I hope you're. I hope you spent more than the half a second I spent this morning. Um, anyway, I'm here just to say hello, welcome, a few things about BIMA, and then I'm going to hand you over to Andy, who's equally well dressed as I am this morning, who's going to run today's session. So, if you've been to these before, you kind of get the drill. These are a monthly masterclass, and the whole point of it is we've got this amazing eclectic mix of businesses and people within BIMA, and we find people like Andy that are willing to sort of share their knowledge, their expertise with the rest of the community, and we do it in the form of an online masterclass, of which this is the November one. So thank you for coming, everybody. The housekeeping stuff is pretty simple. It's a webinar format, but you can engage, and it's best to do that through the Q&A function in the Zoom webinar thingy. And Andy or myself at the end will get round to sort of answering questions and things that you might have. Otherwise, it's fairly sort of passive for you. You can kind of sit back, drink your cup of tea, eat your Marmite and toast, and Andy will take to the floor in a moment. And why this one in particular? If you are in and around BIMA a lot, you'll know that we've got 3 pillars that we focus on where we add value to everybody. And the middle pillar is culture, and we split it down by people and planet. So we've got a sustainability council who are one of the most active councils that we've got. They've put together all sorts of amazing initiatives. So we've launched a thing called Marketing Declares. I'm going to send you all an email about that on behalf of the marketing industry, not just the digital industry. That took place about a month ago. We're launching some web standards on the design and build of web-based products. So let's say RFP stage, you've got something that comes through, you can then send something back and say we adhere to BIMA's sort of guidelines around the design and build of web-based products. There's a lot we're doing. We've also got a carbon net zero course. I think there's a lot of ignorance out there still around the impact that digital has on the planet, and it's huge, right? We keep hearing this statistic that it's the same or even not, if not bigger than the airline industry. So the more we know about this, the better. This is going to be geared to a slightly more technical audience. But Andy's told me that 30% of it is just going to be of general interest anyway. So let's do stick on board, because ignorance around these subjects is not good. If you're like me and you're not necessarily that technical, you're going to learn some stuff. That's kind of it from me. We've got a couple of other things coming up that I need to tell you about, completely different to this, but equally as important, I think. Tomorrow, we've got an event from our Wellbeing Council, specifically geared to men's mental health. We've got some really interesting speakers. On the flip side of that, we've got something next week called the Shima Networking Power Hour, which is to support women in tech. So you can just rock up to that and meet some really interesting people. And there's also a new business peer group next week. But we've only got an hour. I think this is about, Andy, it's the 10 do's and don'ts of sustainable systems design. Andy, I think I've set you up. Can I let you run with it? And thanks so much for doing this today.
Absolutely. Thank you, Matt. And thanks, everybody, for coming. Let me just share my screen and we'll get cracking. Okie dokie. There we go. You should be able to see a well-crafted deck. 10 do's and don'ts of sustainable systems design. Okay, so today we're going to cover lots of stuff. We're going to go through 10 do's and don'ts. And as Matt said, it's not all technical, but it is largely technical. Big caveat, I'm a software engineer, so if I shut my eyes, I do see ones and zeros, but I'll try and make this as digestible as possible. So we're going to cover lots of stuff, from how much legitimate traffic actually reaches Chinese businesses, the true statistics around bots and bot traffic and their effects on the environment, and cover some exciting news around some new projects that were donated to the CNCF announced in KubeCon this year. So let's get going. Right. Oh, bear with me. Why isn't that changing? There we go. Right, good. We're rocking and rolling. First one, don't think your applications don't have a difference. So to do this, we're going to look at carbon emissions by our industry. And there are 4 main polluters in the world. It's agriculture, industry, infrastructure, and transport. Now, these guys here have a heavy reliance on burning fossil fuels. And if they don't sort their shit out, we're all doomed, to be honest. But it doesn't mean that our community can't have a positive effect. So we fall under the sector ICT, which stands for Information Communications Technologies. Now, ICT makes up things like the internet, workstations, phones, and therefore data centers. And data centers need two things in huge abundance. They need lots of power to process all of that data, and they also need large amounts of water to keep them cool. And this is where we have most of the environmental impact on the planet for our industry. And there's some crazy statistics out there. I saw that Bloomberg this year announced that Bitcoin produces the same amount of carbon as the whole of Argentina in a year. So start looking at it that way, right? Some of these technologies have a real impact on the environment, and the emergence of large language models and ChatGPT are going to have like a very much compound effect on that. There's some research that came out recently that ChatGPT itself, when it gets added to Bing search or Ernie to Google, or Ernie to Baidu, or Bard to Google, will be about 4 times as polluting as a regular Google search. And the Sunday Times predicted that a regular Google search at the moment uses the same amount of carbon as boiling half a cup of water. So you can start to do the maths, right? Billions of people use these searches a day. So like the impact of our industry on the environment is real, and it has real effects. A guy called Mike Berners-Lee, that is Tim Berners-Lee's brother. Tim Berners-Lee obviously invented the internet. What a powerhouse of a family, right? He's a lecturer at Lancaster University and the author of The Carbon Footprint of Everything and How Bad Are Bananas. He predicts that ICT, our industry, produces around 3 to 4% of global emissions in 2022. So obviously there's a big difference between ICT and those traditional producers: transport, infrastructure, agriculture, and industry. However, those industries are becoming increasingly reliant on ICT to become more efficient. Also, internet usage is on the rise. Since 2012, consistently year on year, there's been increases of between 4 and 12% of ICT users. So it's largely predicted as time goes on, ICT emissions will rise with new technologies being adopted and increased adoption of web technologies. And the major polluters' emissions will have to fall, and there'll be increased reliance on our industry for them to become more efficient. So the cloud, there's lots of cloud providers out there: Microsoft's Azure, Google's GCP, AWS, for example. This infographic you can see on here comes from Azure, and all the cloud providers have lots of initiatives about becoming more green. So this is Microsoft, as we said. They've been carbon neutral since 2012 through a series of carbon credits, which isn't necessarily like solving the problem, but it means they're offsetting that problem by putting money back into carbon schemes. They've pledged to be carbon negative, so that's putting more carbon back into the offsetting more carbon in the environment than they're producing by 2030, and offset all the carbon ever produced by Microsoft since it was established in 1975 by 2050. They've pledged to be running on entirely renewable energy by 2025 and be zero waste and water positive by the same year as well. Now, all is not rosy. In 2021, during the pandemic, Microsoft's emissions actually rose by 20%, which is the equivalent of 14 million tons of carbon. That's because there's increased use, and they may be offsetting it, but we're using more carbon than ever, or using more cloud services than ever. Also, there's lots of critical people out there around the initiatives and the policies they have in place. For example, the water policies they have, they don't necessarily replenish the water in the communities they're directly affecting. So if you have a data center, so for example, in Arizona, and they're taking water out of the Colorado Basin, which is something that is happening on a day-to-day basis, they're not necessarily putting water back into that community that's being affected. They're replenishing on a global level. And around the carbon offsetting point, again, it's not it's there's a lot of critics out there, and you're throwing a lot of money at the problem by offsetting the carbon you're producing, but it's not necessarily meaning that you're not producing that carbon. You're still producing more carbon than ever. So it's time that we as a community start to think about how we use the cloud and these applications and start to make a difference. So first, the next do's and don'ts is a do, but it's do take a green approach to systems design. It's not a mutually exclusive benefit. So let's start with talking about how websites produce carbon, first of all. So you've got a website and you've got a browser, right? That's pretty standard stuff. That browser will make a request out via the internet to a web server to get some HTML, right? And send it back across the internet. And that's how the internet works. The web page itself will produce carbon, and today we're going to go through some tips about optimizing that web page. The requests on across the internet will all produce carbon. So depending on how far you're traveling across the internet, it will produce more carbon, and the web server itself will be producing more carbon to calculate all the data it needs to produce this web page. So there's carbon all the way along that chain. Now, the way modern cloud computing is costed is every single jump across that chain and all of that performance and processing costs money. So if you start to take certain architectural principles to reduce your carbon emissions, by the very nature you're reducing your reliance on the data centers, the amount of processing you need or the amount of compute you need. And as a result, that will be saving you money. So first of all, you can save cash, right? As well as be more sustainable. And as a result, users will have greater performance because you're going to be sending less data across the wire. Hence, the pages will load quicker and the users will be having a greater user experience and greater performance. So there's three linked benefits here: cost saving, sustainability, and performance. And you can have it all. And the techniques we're going to talk about today will show you how to achieve that. The next is a don't. Don't assume your website is carbon neutral. And this is the best place to start. First of all, it's about how do you know how polluting your website is? And this is around reporting on carbon metrics. Now, there's a bunch of tools out there. Some people might have used the website carbon calculator, which is a simple tool. You can drop your URL in, it will do some calculations to figure out how pollutant your front end is. It will give you some carbon stats back and tell you how much carbon equivalent you are in flights and the weight of sumo wrestlers and interesting facts like that. Also, the major cloud providers all have carbon stats and carbon reporting as part of their billing metrics. So if you own the space that your sites are hosted in, as part of the billing metrics in AWS through the customer carbon footprint tool, or through GCP's carbon footprint tool, or in Azure via either the emissions impact dashboard, which is a Power BI plugin, or the Cloud Sustainable API, which is in preview at the time. So I think it's probably out of preview now, but there's a ton of ways you can get these carbon metrics. It's also worth noting here that Azure do seem to be the best cloud provider in terms of publishing those metrics and making them available. They seem to be taking a lot more steps, in my opinion, than GCP and certainly AWS in like awareness around carbon computing and the sort of schemes those guys have in place. Now, there's an open source product called the Carbon Footprint Dashboard. There's a link on the screen here that will pull all of this data together for you. It's really easy to implement if you have a technical team or some DevOps engineers, and it will pull together all the metrics from GCP, AWS, and Azure into a single tool, which gives you carbon metrics over time. So you can start to check whether the changes you're making to your systems are reducing the amount of carbon they're producing, as well as like give you the metrics you need for offsetting, for example, if you decide to take that strategy. So number of trees you would need to plant, whatever, to offset your websites. We've implemented these for all of our clients, and we have them as part of our QBR process. So we report on carbon metrics and try and show down initiatives on driving carbon metrics down. And we've recently done a lot of this for Reed, the recruiters, and they've been incredibly impressed by the sort of initiatives we've been having and the impact we've been having from the the changes we've been making, and they want to roll that out across their business. So like clients are up for this. Also, it's worth noting that as part of the EU rules coming up in 2025, there's something called the greenhouse gas emissions, and there's three scopes to it: scope 1, 2, and 3. Scope 1 and 2 are about direct emissions an organization produces, and scope 3 is its supply chain. And we are likely to form part of our customers' supply chains. And we do, right? So as part of scope 3 of the greenhouse gas emissions protocol, we will need to start reporting on the emissions our systems produce. And again, these sort of tools here are a great starter for doing that. And if you're entering things like B Corp or something like that as an organization, again, this would go a long way towards a lot of B Corp points because it gives you that observability into the products you produce. Right, the next one. Do optimize the UI and the client-side experience on scripts. So this is where it starts to get a little bit more techie. But here's a bunch of 10 tips, and there's actually nine for the price of one here. But this is stuff you can do on the browser to make sure that you're optimizing it for a carbon-friendly experience. First of all, take a mobile-first approach. So you make sure that you optimize for your worst journey, make sure all of the scripts and bundles and images and everything like that are as optimized as possible for mobile. And then design up from that point will help reduce the amount of load that's having to be loaded into the browser, how quickly it performs operations to get the page up and running, and hence produce less carbon. Use carbon aware design. So this isn't a UI course, but there's a bunch of points you can look at around carbon aware design. How bright the assets on the screens are, for example, how many fonts you're using, or the size of images. All of this sort of stuff will have a direct effect on the amount of carbon that your websites produce. You can consider point 3 here, carbon toggles, and on the right hand side you'll see something from Boohoo's site, which is quite ironic considering they're a fast fashion brand and probably having a lot more impact on the environment than their website is, but they have an energy saving mode on their site, and that's something we're starting to see a lot of people introduce, like accessibility modes and energy saving modes, where they overlay dark overlays on the screen that reduce the brightness of the colors, hence reducing the amount of energy your monitors need to show them and having a positive effect from an environmental perspective. Optimize your images. There's obviously like a bunch of ways you can optimize your images, but there's like WebP, there's AVIF, which is a new format that's coming out that's going to be supported by all modern browsers soon. And if you look at something like, switching a JPEG to WebP, you can reduce the total size of the image by 89% while still maintaining 75% of the quality. So you're going to have a quality size ratio that you have to adjust. There's huge gains to be made by optimizing with WebP without reducing the quality of the image. So well worth looking into. Next point 5, is about bundling all your assets. So that's all your JavaScripts and stuff like that. Make sure you bundle them into single files as a single HTTP request for them. And those bundles are as small as possible. That's going to have an increase on performance, and it's going to also have a benefit from a carbon perspective. Optimize your JavaScript. So this is like things like running Lighthouse and looking at your time to interactive and those scripts that are hanging and how long they're hanging for, and all of that will have an effect from a carbon perspective. Limit the number of libraries and third-party fonts you've got, obviously. Things like videos, make sure they don't autoplay. Not everybody wants the videos to play, and obviously that's going to be loading more data from a HTTP perspective and having a negative effect from a carbon perspective. And last point 9 of this section is about loading in your dependencies on events rather than on page load. So a good example of this is a chatbot. Now, how many percentage of users actually use chatbots? Now, it depends on your website, but typically, it can be quite low. It's certainly not everybody that visits, your website will be automatically engaging with a chatbot. And to load a chatbot into a page, they normally have some quite big chunky JavaScript files because they're quite involved, right? And you could be loading like 4 megs worth of JavaScript into the page. Rather than loading that in for every single user, and not everyone is going to interact with it, just load it in on the click event so that only the people that are using it have to load in that file. Okay. Point 5, don't ignore user data, volumes, and locations. Now, we're going to look at a monolithic application now and how a monolithic application processes a web request. And we kind of covered this a bit before, but we're going to look at it in a bit more detail now. And then we're going to look at a technique that we've used across Reeds, UK Power Networks, and IWG and SAP actually to implement real carbon savings. And this is one of the best techniques we've seen have a positive effect. So you've still got your web page. We've talked about optimizing that, and it comes through a client, and this client or browser is in the UK. It makes a request out to the internet to, say, for example, a web server in Denmark, which is fairly close geographically, right? Which is fine. That web server then might have to make a request to an application server, which might have to get something from a database or pull something from a CMS or an API or whatever it needs to do to get all the data together for that web page. It will then calculate some HTML. And I'm not suggesting you're not going to have caching policies and stuff like that, but this is just a very crude example about how a web page is produced in a monolithic application. That's then sent back across the wire to the browser. So now the browser will be producing carbon. We've talked about that. All the hops across the internet will be, and every step inside the internal network will also be producing carbon. Okay. Now, if those users are in the US, that request is going to have to travel a lot further, producing a lot more carbon. Or if they're in China, for example. And this is something we need to consider. We need to consider our geographic split around where our audiences are based and how we produce this HTML. Now, enter something called static site generation. Now, the theory behind this in a nutshell is rather than producing the HTML every time you refresh the browser and request the page, it's all produced up front, pre-rendered. And it's then distributed on CDNs and it's delivered to people much closer to where they're geographically based, and you're not producing the HTML every time, saving money, massively increasing performance. You see like staggering performance of like time to first bytes in absolute milliseconds, and reducing the amount of carbon. So here you've got a CMS, and this says Umbrico under it. It could be Umbrico Arc was one of the CMSs we use at Tangent, but it could be any headless CMS. So content's being provided by an API, in other words. That inputs the content into a static site generation application, which would then create a web page, as we talked about, which would then be stored in cloud storage and distributed via a CDN. And then users would then request that pre-rendered page locally to them. So if they're in China or if they're in the US or if they're in Denmark or UK, they're requesting it locally to them. Then anything you can't pre-render, say for example, you've got something like a share price on there, there will be an asynchronous request back to that web page just to get the share price, but not the whole page. So it's much, much more efficient from a carbon perspective. So if we look here from our original example, you've got our UK user, our user in the US, and our user in China, and they're all just making requests to that CDN, meaning that the amount of distance you have to travel to get the page is much less, producing less carbon, and performance is absolutely staggering. And then anything they can't pre-render, then will go to an API and a list of backend services to generate. And obviously there will be a carbon fit there, but it's greatly reduced compared to the monolithic application. Now, with UK Power Networks, for example, we saw the old homepage produce about 1.44 grams of carbon with a monolithic approach. When we changed it to the new approach, it produced 0.2. And to put that into perspective, when Storm Eunice hit, there were about 3.2 million users that went to the UKPN site. Just the homepage carbon savings alone were the equivalent of 9 flights from London to Copenhagen in one weekend. And most users would have gone to 3 or 4 different pages. So you can see that, you start to see how, as Matt said at the start, the web industry and our industry are producing more carbon than the aircraft industry. Okay, next point. Do optimize the HTTP requests and transfer of data. So this is around APIs, and you've got, this is about evaluating something like REST versus GraphQL. So the way REST APIs work is you normally have a bunch of different endpoints. Say, for example, here you've got customers, orders, and products. If you need to request that, you might need to request the customer, then request all the orders for said customer, then request all the products for that order, which would be 3 different HTTP requests across the wire. With the use of something like GraphQL, you can aggregate those requests into a single HTTP request. So rather than having to make 3 different requests to get the customer, the orders, and the products, you can make a single request that would then aggregate all of that data into a single feed for you. You also only request the data you need. So say, for example, you only need customer's first name and like a list of product names and an order number, for example, rather than getting everything that belongs to the customer, like you would with REST, like the first name, last name, email address, etc., etc., etc. All the stuff that belongs to orders, like order create date, order ID, etc., order status, yada yada yada, and all the stuff that belongs to products. You can only request with GraphQL the fields you need, so it massively reduces the size of the request going across the wire, increasing performance and also decreasing the amount of carbon you're producing. Okay. Next point: do migrate to SaaS or PaaS. Now, this is one of the big ones, and this is the sort of thing you hear quite a lot mentioned when you look at the cloud providers, obviously, because it's a source of revenue for them. But Microsoft estimate that moving from an on-prem data center or hosting provider to PaaS could save you 95% in carbon. Now, obviously, it depends on how much you utilize your on-prem services. But the gist is that PaaS and SaaS services are shared, right? They're physical resources that are shared between lots of people, and you're only using the bit you need or the bit you're paying for. So hence, it would massively reduce the amount of carbon you're using, which makes sense, right? It's also widely recommended to decouple services and look at microservice architectures. So compared to the monolithic application we saw before, where, say, for example, you had like your pricing service built into your monolithic application that was also providing your customer services and producing your web pages. If you decoupled that pricing service into an individual application, it can scale individually rather than having to scale the whole thing, which is inefficient, will cost you money from a hosting perspective because it will be using more compute and also be producing more carbon. So by decoupling your services into lots of individual applications, and they can scale individually and go up and down as they need, much better from a carbon perspective. It also allows you to look at right sizing your infrastructure. Now, this makes sure that the plans you've got for your infrastructure are the right size, right sizing. Funny enough, and that means that you're only paying for the resource that you absolutely need. So you look at your BAU traffic, you optimize for your BAU traffic, and then you put auto scaling policies into scale for when you have spikes in traffic, maybe around like particular events or unexpected spikes. And that's looking at auto scaling policies. So those points there are hugely important from a cost saving perspective. You should all be doing that anyway, because cloud services are expensive, and like from your client's perspective, there's this huge benefit in right sizing your infrastructure and scaling with it, but also from a carbon perspective. We've talked around distribution of assets from a CDN perspective, but the closer you can distribute your assets, not just pre-rendered pages, but images, JavaScript, fonts, whatever you've got that you're loading in from your web servers, the closer you can distribute that to the end user, the better the performance will be and the less the carbon will be. The next point is around malicious and bad bots. Now, Imperva released a bad bot report. In 2021, they estimated that only 57.7% of all traffic to all websites across the world was from humans, right? Let's think about that for a second. Only 57.7% of all traffic is from humans. 14.6% is from good bots. This would be things like Google trying to index your site and rank your site. But a whopping 27.7% of all traffic across the globe is from bad bots. This is like malicious bots trying to scrape your sites and figure out like if there's any vulnerabilities on there, whatever they're trying to do, or scrape data from them for whatever it could be. And you can block these bad bots. If you've got a web, if you've got a firewall, like a WAF, you can generally put rules in to block bad bots, instantly reducing the traffic going to your site by 27.7% and reducing 20.7% worth of carbon. The next point's around DDoS protection. Now, obviously, you should be doing this anyway, but Cloudflare this year released their DDoS trend report. It's a really interesting report to read, by the way. It covers like lots of interesting facts around like attacks around the globe, and this year's was absolutely fascinating. They reported that 93% of all level 3 and level 4 traffic, that's like the network level, to Chinese registered businesses was malicious. So only 7% of traffic to Chinese registered businesses was actually legitimate traffic. This is coming from Cloudflare. They're a very reputable provider. It's very similar in Lithuania and Finland. In Lithuania, it was 87% was bad traffic or malicious traffic, and in Finland, it was 80%. That's to the network layer. If you look at like the application layer, level 7, which is like the HTTP request and everything that goes over the browser, 42% of all traffic to Georgian registered businesses this year was attack traffic. It's a huge amount of percentage of traffic going over the internet is malicious. Certainly at the moment, it's like there's lots of geo political pressures, and there's lots of new threat actors out there, and we've certainly had to deal with some in our former work at Tangent. We're dealing with like enterprise clients over the globe, and it's important that you handle this correctly, not just from a carbon perspective, from an information security perspective as well. And again, you can put DDoS protection in the cloud at subscription levels that will block large amounts of this, but it's certainly something you should be doing. The next point is around turning non-production environments off out of working hours. So say, for example, you've got a dev, test, or stage or UAT environment, turn it off if no one's using it. Again, if you're using like cloud native or something like that, like containerized applications, it's much easier to spin these up and spin these down. Which leads on to the last point around adopting cloud native design patterns to reduce resources. Now, I don't know if you guys are familiar with cloud native, but there's an organization called the CNCF, the Cloud Native Compute Foundation. They're an independent organization, and they own Kubernetes, which is a container orchestration product. It was donated to them by Google. And some interesting points around Kubernetes, and this is super geeky, but I'm a tech director, so I had to be a little bit geeky. But the original cloud orchestration platform from Google was called Borg, after Star Trek. And they wanted to call Kubernetes 7 of 9, which was a female Borg officer that worked for the Federation. I'm not into Star Trek, by the way, so if I'm saying this wrong, yeah, apologies. So they wanted to call Kubernetes 7 of 9, but they weren't allowed to for legal reasons. But if you look at the Kubernetes logo, it's a ship's wheel that's got 7 spokes around the outside, and that's in tribute to 7 of 9. Anyway, I'll get back on track. So Kubernetes is a container orchestration platform. It means you can spin up pods and share resources between pods, and there's also a bunch of cool projects you can use that are donated to the CNCF. This year, Header, which is an event-driven autoscaler, meant you could scale your operations based on carbon metrics. And also this year, Kalpa was donated by Red Hat to the CNCF. Now, Kalpa is a really cool observability plugin for your clusters that allowed you to report on carbon metrics for your clusters. And there's 2 QR codes there. So if you're interested in these and you're using Kubernetes and you want to take advantage of being able to scale your application up and down based on carbon metrics, there's Kedar. Or if you want carbon observability into your clusters, there's Kalpa. Well worth having a look. Right, next point. Don't forget to patch. This is a really simple and obvious one, right? We should be doing this anyway. But patching your application will give you security benefits. It will also give you performance benefits as new features, but those performance benefits have a significant advantage from a cloud perspective. So don't forget to patch your applications. The next one is use design patterns, and I'm about to go through a design pattern now, but with design patterns ultimately are around like reducing stress on your systems, making them more interoperable, making better placed designs for your systems, and they have a large effect from a carbon perspective as well. We're going to go through something called the circuit breaker pattern. It's largely used in microservice architecture, and it falls under the sustainable design patterns category. So if you have a little Google for sustainable design patterns, you'll see that there's a few out there now, that it's a trend that's forming from a web development perspective. So microservice architecture typically have lots of services, right? And they call each other. If a downstream service is like slow, or it's intermittent through like slow network connections, timeouts, or being temporarily unavailable, the typical way you'd solve this problem is to try and recall it continually to resolve the problem. However, if that service or it has a severe issue, or it's unavailable for a long period of time, by recalling and recalling and recalling it, it can cause your network resources to become exhausted and also burn a huge amount of carbon. So hence enter the circuit breaker pattern. And now there's 3 states to the circuit breaker pattern. The first one is the closed state. So think of it like an electric circuit, right? If all the bits are down, electricity is passing around and everything's absolutely hunky-dory, hence the closed state. And here you've got a client that's calling a circuit breaker pattern service, which is calling a downstream supplier microservice. And everything's absolutely hunky-dory here. But say, for example, that supplier microservice hits an error and there's a problem. The circuit breaker pattern will try and recall it a few times, and it will hit a threshold. And at that point of hitting the threshold, it will switch the architecture, or sorry, switch the state into open, meaning that the circuit breaker pattern will just return an error. It won't be continually trying to hit that supplier pattern, calling and calling and calling and calling. After a period of timeout, it will go to a state of being half open, where it will periodically call the service. And if it's returning errors again, it will go into the open state. And if it starts to respond, it will go into the closed state, meaning everything's fully functional. Now, this is the sort of services that people like Netflix use. So Netflix are one of the big sort of microservice pattern case studies out there, and everyone knows about them. And they're using techniques like this to try and reduce the amount of carbon that Netflix uses. It's worth noting in 2018, it was reported that Netflix uses the same amount of carbon as the whole of Qatar. So again, quite big stakes in these providers using these sort of architectures. Lastly, number 10, when and where you process your data makes a difference. Now, not all data centers are created equal. Microsoft, again, I'm keep using Microsoft as an example, but they're all very similar, have a bunch of policies at a data center level. And here on the screen, you can see West Europe. They have like zero waste, water positive policies for each region. And not every region across the globe will have these policies. So it's worth checking where you're processing your data, certainly if you're processing your data in large volumes, and making sure you're picking regions that benefit from all the sustainable policies that these cloud providers are putting into place. And you can find these by going on to, like, in this case, the Azure Global Infrastructure Map, clicking on the region, and there the little boxes in red show you the policies they have in place for that particular reason. Now, something like zero waste means that the data centers divert 90% of food, office, and construction waste from landfills into like local recycling and composting programs, which again, these data centers do produce quite a lot of waste. So it has significant benefits from a local level. Now, picking these dense data centers and designing these systems the way we've been talking about today falls under the category of design-aware computing. And another thing to consider as well is around batch processing. if you're processing huge amounts of data periodically, it's best to process them outside of peak times, much like you had advice around, using your washing machine and using your washing machine in the evening when not everyone else is. It's very similar to processing data. And it's a good idea to try and schedule these when there's a surplus of electricity. There's an extra one. There's an extra, it says 10 do's and don'ts of sustainable systems design, but I was feeling generous, so there's an 11th. These are the 3 things I'd like you to take away from today. The first one is the systems we've designed have an impact on the environment, so the time to act is now. The next point is that HTTP requests result in carbon emissions. So by optimizing your HTTP requests, like we talked today, you're going to be having a positive effect on the environment. And lastly, the optimization of your systems will increase performance, save you money, and reduce carbon. So why wouldn't you do it? There's a downloadable report we've put together at Tangent, which has a lot of this information in. The QR code's on the screen now. So if you want to snag this, it will give you lots of benefits from a composable system perspective, from a marketing perspective, operational and technical perspective. My name's Andy Everdale. I'm the technical director at Tangent as well. If you want to reach out to me and have a chat about what we've discussed today, please add me on LinkedIn and drop me a message. I'd be more than happy to talk to you. But thank you very much for your time. Let me see if we've got any questions. 2 seconds. How do I see the questions? Oh, here you go. Big Q&A button.
Yeah. Hi, Andy. How are you doing? I can help out with that if you want.
Thank you. Yeah, that'd be good.
That's brilliant. Thank you so much for doing that. I hope everybody enjoyed it. It's fascinating. The stats are just crazy, right? Was it the last one you read out? Netflix and the whole.
Yeah. The scariest one for me has to be that Bitcoin produces the same amount of carbon as the whole of Argentina.
Yeah.
It's absolutely mad, right?
No. Argentina, not a small, that's a big country.
Absolutely.
So the question was about some general stuff, information from BIMA, which is something I can follow up on. Does anybody else have anything that they wanted to put through? Here we go. Going back to the front end, how backwards compatible is that new image format that you mentioned?
Oh, AVIF. Yeah, WebP is still the given, as you put there, not WebP. So most people are using WebP. AVIF is something that's probably going to be coming into browsers. Yeah, that's it. Next year. So it's not completely backwards compatible at the moment. It's only being adopted by modern browsers now, and you're also finding that when you look at image optimization packages that come with things like Next.js or Gatsby, they're not quite supporting it yet, but it's on the horizon. And when it is here, there's going to be there's lots of talk about how positive it's going to be. So it's more one to keep an eye on in the future rather than something to adopt straight away. WebP is still the given format at this point in time.
Great. I mentioned the thing Marketing Declares that it is born from the Sustainability Council. I've just put the link to that in the chat. If anybody wants to click and go through and have a look, that would be great if you could support the cause.
Mm-hmm.
Okay. Well, unless anybody has anything else to put in there, that's oh, here we go. What are some of the common challenges associated with trying to retrofit sustainability changes to brownfield existing applications?
Well, absolutely. I guess firstly, depends how legacy your application is, right? But if you're on-prem, there's obviously always cloud migrations can be challenging, and that's one of the most important things you can do. So I think when we did this with some legacy applications, and some of them had code that was 15 years old in it, right? But the way we approached it is we started to look at caching policies, maybe putting things like Varnish CDN in front of it and caching the pages locally on CDNs is something you can do fairly decoupled from the legacy application. There's not too many barriers to entry there. It's also worth reporting. So you don't know how, off the bat, you want to start looking at carbon emissions for those legacy systems so you can start to drive down those changes. But something like Varnish can be a way to implement some of the benefits we've been talking about today in a legacy product or a brownfield product that's fairly low barrier to entry. And of course, they have massive effects from performance perspective and from like, utilization of your existing services and data center, etc.
Okay. Andy, I've got a couple more I'm going to read out if that's okay.
Sure.
So, one from Helena. I've been reading about micro interactions and motion storytelling on interfaces as continuing trends. How do we convince clients to own team and move away from this to be sustainable?
Yeah, it's a really good question. Like, I don't think, well, not all of the clients we're talking to at the moment, carbon isn't like number one on their agenda, or it can be on their agenda, but it's not necessarily from a web perspective. Say for example, you're dealing with somebody that has a big physical presence and they've got like large fleets of vehicles or something like this, right? They're very much focused on carbon emissions in their operations, but web can be a forgotten subject. Now, step one is around reporting. As I said before, it's about like showing them exactly the impact they're having on the environment. And if you do QBRs, you can bring like sustainability or carbon emissions into your KPIs. That's like step number one. It's awareness around like the problem and the impact they're actually having. And then step two is around trying to optimize those experiences. So you don't necessarily, there's always going to be a balance between the experience you give to the end user and like the amount of emissions you're producing. And it's about like having those conversations. It's about saying like, if we don't always load in those interactions, or maybe we do it in a slightly different way, or we lazy load some in, for example, or we heavily optimize on certain types of devices, or whatever it might be. It's about starting to have those those conversations and then make them aware of those carbon KPIs and start to drive them down. But it is challenging and it's not always like a clear path. I'm not going to lie to you. We it's something we had to start by educating our clients with to start off with.
Okay, thanks. I've got one more for you, Andy, before we go.
Sure.
From Emily, do you know of any methods to calculate? Oh, I'd like to know this as well. Any methods to calculate the emissions of an app rather than a website?
Yeah, no, sure. Now, the carbon website calculator before we used, that's purely websites. You put a URL in, it's not for apps. If you look at app usage, there is something called co2.js. Depends how your apps are built. We build a lot with like React Native, for example, so we can take advantage of some of these. But co2.js is something you can run on the app, on the web app itself, and then you could send like uh, the statistics back asynchronously to like a back-end logging or monitoring tool like App Insights. And we've done that with some of the web apps we've been running. And also it's worth bearing in mind that you still can use all of the native cloud tools for any of those APIs that are providing data to those web apps. So any of your downstream systems, you can still monitor and get the emissions from like all your billing data within the clouds. And then on the web app itself, if you're using like React Native or something similar like that, then there's a library called co2.js, which is well worth checking out.
Okay. Right. I think we're all, what big changes do you think are coming next in this space?
Well, I think that there's going to be a reality point that hits where, like, don't get me wrong, the BBC did a documentary recently, a panorama documentary recently on cloud and data centers and how dirty the internet is, but it's something that's not being taught. So I think there's going to be a reality check. And we touched briefly before around like large language models and generative AI and the impact it's going to have, but that's a wave that hasn't hit yet. Like they haven't been fully adopted into cloud search, like web search yet. And when that happens, I guarantee you that there will be huge. I don't think people are really talking about it yet, but I think more people will be talking about it when it happens. It's going to happen, right? Like it's going to Google will and Baidu and Bing will all be adopting like generative AI into search, and I think that's probably the big changes that's going to happen is the adoption of some of these pollution technologies, and things like Web3, right? When you look at Web3, and we talked about Bitcoin earlier on, and like the impact that like that blockchain technology is having already compared to Argentina. Imagine when all of our data is all stored in the blockchain and we own it centrally, the sort of impact that's going to be having on the environment. Like these technologies are coming, and the environmental impact is going to be an afterthought, unfortunately. So we're going to be left as an industry implementing the technology, in my opinion, then having a mop-up exercise afterwards. I don't think carbon and the environment won't be a blocker to change, but we will have to act on it once that change happens.